Welcome back. In the next part of this lecture, we'll be talking about using our sum and difference identities for sine and cosine and tangent. Okay, so in this example, we've got ourselves an angle that we happen to know is in quadrant 2, and we know the value for sine of that angle. And what we're interested in is the value of cosine of that angle minus pi over 3. So the first thing that I'm thinking about here is if you're looking for cosine of theta minus pi over 3, that's cosine of one angle minus another. So we know that we could just use our difference identity for cosine, that it would be cosine of the first angle times cosine of the second plus sine of the first angle times sine of the second. And that means that we've got some things that we already know. We know what sine theta is. That was given to us as a third. We know that we could find sine of pi over 3 and cosine of pi over 3 just using our special triangles. But we would still have one thing left to figure out, which is what is cosine of theta. So before we use that before we use that difference identity, we're going to first need to figure out what is cosine of theta. So that's going to be my plan here. I'm going to first find cosine of theta. Then once I know cosine of theta and sine of theta, and I've got my special triangles, then I'll be able to use that difference identity. So now as far as finding cosine of theta goes, this is sort of old news. You know what you would do in this case. You would draw your angle in quadrant 2. And if sine of theta was a third, then you know that sine of theta is defined as y over r. So the point that we pass through, we could say that it has a y-coordinate of 1 and an unknown x-coordinate, but that r happens to be 3. And we could figure out what x is using our formula, that r is equal to root of x squared plus y squared. And we find that x squared is 8. And solving, we find then that x is, in this case, negative of square root of 8. The reason we know it's negative is because we happen to be in quadrant 2, and in quadrant 2, the x-coordinate has to be negative here. So x is negative root of 8 or negative 2 root of 2. And so once we know that, we can say, well, that means then that cosine of theta should be x over r, which is negative 2 root of 2 over 3. So now we've got most of what we need in order to actually find the answer to the given question, which was, what is cosine of theta minus pi over 3? And as we said, we were going to use that difference identity for cosine, that if you're looking for cosine of one angle minus another, that would be cosine of the first angle times cosine of the second plus sine of the first angle times sine of the second. And we've got everything we need. We know that cosine of theta is negative 2 root 2 over 3. And then just using our special triangles, you can find that cosine of pi over 3 is a half. We were given that sine of theta was a third. And sine of pi over 3, again, using your special triangles, that is root 3 over 2. So we get negative 2 root 2 over 6 plus root 3 over 6, which you can make into one fraction as negative 2 root 2 plus root 3 all over 6. Okay, and for this example here, we've got a couple of things that we are given. We have two angles that happen to be in quadrant 1, and we're told what sine of that angle alpha is, and we're told what cosine of beta is. just to be careful here, these are two angles that are in quadrant 1. They're not necessarily complementary angles, so we can't guarantee or assume that they have to add up to 90 degrees. They just happen to be two angles that are in quadrant 1. If I'm thinking about the question itself, tangent of alpha plus beta, I know that tangent of alpha plus beta is going to be defined in terms of tangents of alphas and tangents of betas. Because if you're remembering the formula for tangent of alpha plus beta, that would have been tangent of alpha plus tangent of beta over 1 minus tangent alpha tangent beta. So before we can find the value of tangent of alpha plus beta, we'll need to know the values of tangent of alpha and also tangent of beta. So that's sort of my plan here. I'm going to start by first finding tangent alpha and finding tangent beta, and then once I've done that, then I can go on and find tangent of alpha plus beta. So firstly, let's start by finding using sine of alpha to find tangent of alpha. So the first part that we know is that these angles are in quadrant 1. And you know that sine of alpha is 3/5. And remember, sine is y over r. So we can take the y value as being 3 and r as being 5. And so you can do the same thing that we did in the last example by using the formula that r is root of x squared plus y squared to find out what, in this case, x needs to be. So we can find out without too much difficulty here that x squared is 16. And so that means that x should be, in this case, we're in quadrant 1 where the x-coordinate is positive. So it's the positive root of 16, which is positive 4. And once we have the value for x, we can now say what tangent is. That tangent of alpha should be y over x, which is 3/4. And now I'm going to do the same thing, but for beta. Beta here, we have that it passes through a point in quadrant 1. Our angle's in quadrant 1. A cosine of beta is 12/13, and cosine is x over r, so the x-coordinate is 12, the y-coordinate is unknown, and r is 13. And now doing the same thing that we had, we can find out what, in this case, y is. So squaring both sides, and we'll find that y squared is 25. And because we're in quadrant 1, the y-coordinate is positive, so y needs to be the positive square root of 25, or positive 5. And so now tangent of beta, that's y over x, that should be 5/12. So now we have our values for tangent of alpha and tangent of beta, 3/4 and 5/12. So now the only thing left for us to do is for us to evaluate what is tangent of alpha plus beta. So let's do that now. If we're looking for tangent of alpha plus beta, we know that that's tangent of alpha plus tangent of beta over 1 minus tangent of alpha times tangent of beta. And now we just put in what we found. We found that tangent of alpha was 3/4 and that tangent of beta was 5/12. And then I just need to calculate. The numerator is equal to 7/6, and the denominator is equal to 11/16. And then if you simplify, this is 56 over 33. Okay, so we want to establish an identity, and here I see that I have on the left side cosine of pi plus theta. So I'm thinking about, for this identity, I would want to start on the left side. And since I have cosine of one angle plus another, I know that immediately I have something I can do, which is to use my sum identity for cosine. That would be cosine of the first angle, cosine of the second, minus sine of the first angle times sine of the second. And if we're thinking about evaluating sine of pi or cosine of pi, if I'm thinking in terms of the unit circle definition, pi radians, that would pass through the unit circle at the point -1, 0. That cosine is the x-coordinate for that point, which is -1. So cosine of pi is -1. And sine of pi, that would be the y-coordinate, that is 0. And everything sort of cleans up very nicely. You have -1 times cos of theta minus 0 times sine of theta, which is just negative cos theta. So left side and right side indeed are equal to each other. So we now have that identity of cosine of pi plus theta equals to negative cosine of theta is now established. Okay, let's do this identity. And again, I'm looking at the left side of my equation here. I see that that has a sine of one angle plus another. So that's at least telling me something that I could do. I could use that sum identity for sine. So let's start with that left side. Sine of alpha plus beta over sine alpha sine beta. And using my sum identity for sine, that's sine of the first angle cosine of the second plus cosine of the first angle sine of the second. Okay, so what we're going to do now is the opposite of usually what we do. Normally when you have two fractions, you put them together to make one. Here we're going to do kind of the opposite. We have one fraction and we're going to split it into two. Because you've got two things in the numerator all over the same denominator. So that's the same thing as the first term in the numerator over that denominator plus the second part of the numerator over that denominator. The reason why I thought that this would be a good move to make is always looking at the right side of the equation, I noticed that it has two terms, so it makes sense that I want to now split up my right side of my equation here into two terms. So I had one term expression, and I've now split it into two terms, and hopefully one of them will turn out to be cotangent alpha, and hopefully the other one will turn out to be cotangent beta. There is some canceling that we can do right now. We have a sine alpha that can cancel out here, and there's also a sine beta that can cancel out there. And so we're left with cosine beta over sine beta, which, if you're remembering, cotangent of an angle is cosine over sine. So if we know that, then cosine beta over sine beta, that is cotangent beta. And cosine alpha over sine alpha, that is again another cotangent. That's cotangent of alpha. So cotangent beta plus cotangent alpha, or cotangent alpha plus cotangent beta, that's the same thing. That is indeed the right side of my equation. So yes, the identity has been established.